G'day everyone, it's Doug Jackson from DougsWordclock.com. I'm here today to show you how to put together one of our Wordclock controller cards. This is a controller card here, fully populated, and in fact you can see the other side, all the little solder joints. It may look like a little bit of a daunting task, but you'll be surprised how easy it is to assemble if you adopt the approach of just taking it methodically. So in your kit, you'll find a whole pile of components. In IC sockets of various sizes, 18 pin, 16 pin, 14 pin and 8 pin, various integrated circuits, screw connectors, some little crystals, some little headers and connectors. These devices are called capacitors, resistors, diode, voltage regulator and LEDs. Let's just have a look at how to identify the various diodes. So we have here a 10K resistor. We can read this by reading the bands, and the bands are brown, black, orange. Brown meaning 1, black meaning 0, and orange meaning 1000. So 10 times 1000 is 10,000 or 10K. These here are 270 ohm resistors. Now again, we can look at the values and we can say red for 2, violet for 7, brown, red, my eyes are getting older, aren't they here? Red, violet, brown. Brown meaning times 10, so 27 times 10 is 270 ohms. So we also have some capacitors. Let it focus. So this capacitor is 18 picofarads. We can tell it's 18 picofarads because it's got 18 printed on it. These capacitors are 0.1 microfarad or 100 nanofarad. We can tell that because they've got a 104 printed on them. It's a little bit tricky to see under this particular light, but they're there. Then we've got two capacitors. So this one is not helpful. Finger time, haha. This component is 100 microfarad, 25 volt. And you can see that one of the legs is marked with a great big minus. That's the negative lead. Polarization is important for that component. This component here is 10 microfarad, 25 volts. And again, if we look carefully, let the camera focus. I'm not sure it's going to focus on it particularly well. You can read the label. It says 10 UF for microfarad, 25 volts. And again, it's got a great big black band for being the negative lead. If we roll it over, the other side doesn't have a band at all. That's the positive lead. We have the voltage regulator, which is a 7805. So here we can see, hopefully we can read the label on the thing, and it says 78L05. And we've got these diodes here. So this diode, you'll see, it has writing around it. In this case it's 1N4007. You see it's got a little band around one side, a little silver band. That band is very important to polarization. Now I'll clear our working surface off because we're going to need a clean space so that we can actually do the assembly of the clock board. So the clock circuit board is a normal single-sided beautiful green colour board, great tinned pads to make soldering easier, and a nice clear silk screen. We start construction by getting our resistors. This one is 270 ohms, so we gently bend the leads. And the 270 ohm resistors go in location R5 and R3. So again, gently bending the leads and into R3. The orientation of the resistors doesn't matter at all. Some people prefer to have them so that the bands all line up with each other. If that's very important to you, go for it. R1 is the 10K, so 10K, 270 and 270. Roll the board over. Now soldering. So I use a normal Weller soldering iron. I think it's about 25 watts. It's about 30 years old. It's had a number of heating elements replaced. I use a small sponge so that I can wipe my tip to keep the tip nice and clean. So starting off with our soldering iron with a nice clean tip, I also use solder. In this case, this is lead and tin, 60% tin, 40% lead. Again, remember, because it is lead solder, when you use it, be careful not to eat it. Be careful to wash your hands before you consume food. So to actually solder the joint, we use our soldering iron. Notice how we put the soldering iron on one side of the joint, and we feed solder in from the other side. Simple as that. Soldering iron in on one side, heating up the joint, soldering on the other side. The biggest problem that I see people doing when they're making boards that are faulty, and that happens occasionally, is people produce what's called dry joints. Now a dry joint is a joint where not enough heat has been applied. So we just be careful to make sure that our joints are nice and warm. The soldering iron, in fact, look at that. I missed that particular joint. Can you see how it's got this void? Hopefully the camera will focus. Yeah, see how clearly the solder hasn't covered that particular joint. So let's get back in. Soldering iron in, bit of solder, off. Then we use a pair of side cutters to trim the leads. Trim, 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 trim. Beautiful. All of the leads are trimmed, so we can now see that the resistors have been installed and all of the joints are all soldered. Now we're going to use three of these little offcuts. So let's just trim the end off, and we're going to use these as jumpers. So we start by gently bending them over. Going to the top of the board, there are three jumpers, and they're denoted by that point, and that point, where there are little lines on the board. Again, the instruction manual shows you exactly where the jumpers are supposed to be installed. One, let's try that again. Jumper in there and there. Some people like to use a pair of pliers to bend the leads so that they're beautifully square. I just bend them gently with my fingers. Clear those off the work surface. Again, so we've got basically the square shape that we need. We can go in that hole and in that hole. I sure hope that this video is going to turn out so that it's actually helpful for people. That certainly is my intent. I do find that when new people start working for us here at DougsWordclock.com, that just showing them how to build a clock controller is the first thing that we show them. There you go. So you can see that we've got 1, 2, 3 little jumpers installed. They're all sitting and waiting. So let's get in and solder them in place. 1. Where are they? Down there. 2 and 3. Grab our side cutters again, trim them off. Simple as that. work surface clear. So there we go. So I've got my resistors and my jumpers installed. Next components that I generally install the components roughly based on height. So the next components to go in are the 0.1 microfarad capacitors, and they go in location C3 and location C4. So component in, bend the leads a little bit so it doesn't fall out. Again, this component will go into this location here. Location C4, bend the lead gently so the legs don't fall out. The next ones to be installed are the 18 picofarad ones. They go beside the crystal in, I think it's C2 and C3. The legend on the board is slightly obscured by a hole. So next time I have some of these boards etched for me by the wonderful PCB cut people in China, I'll get them to move the label for me. We'll put in the little crystal which can go in there. Again, bend his legs gently. That'll do for this load. Again, we'll grab our soldering iron and our solder, and we'll go 1, 2, 1, 1, 1. Push it back down. Make sure that I'm in the center of the frame. The interesting thing about making this particular video is it's being done in one single shot. I don't have any video editing software on my list of things to do one day. And I've got this little square marked out that says stay within this space and the camera can see. There you go, clear that off. And of course I'm working upside down, which is never ever very helpful. Okay, so we've got those components in place. Now let's install the little push button. You'll notice the push button has a basically rectangular, it may be a square push button, but the legs are off one side. So you'll notice that the place where it goes in is slightly rectangular, so we can put the component in that spot there. Gentle push and it just stays. Let's do the voltage regulator. Now the voltage regulator is if we have a look carefully, let the camera zoom in on it. You notice that it's a D shape, and you notice that the pad, the place where we're going to put it, is also a D shape. So just line up the D shape, gently slide it in. Now our two electrolytic capacitors. You'll notice that the circuit board has printed a tiny little plus, a tiny little plus on the square pad. So the 10 microfarad capacitor goes with the positive lead in there, ka-ching, and the 100 microfarad capacitor goes with the positive lead in there. In this case, the positive lead is also longer. I wouldn't necessarily rely on the fact the positive lead was longer. You may be a little bit surprised by the results. Always go by whatever the markings are on the board. Again, gently solder these in place. 2, 1, 2, 3, 1, 2, and the push button. Now the push button is very important. It's never used inside the clock, but it's used for when I was developing it. But it actually provides two wire links on the top side of the board. So if you try and assemble the board without putting the push button in place, the clock won't actually function. It's actually required. And again here, come in and just touch up the joints where you may have missed because you're a little bit quick. So the next component to put in is the diode. Now, do you remember there was a little a little white band. So the white band is on this side. Gently bend the leads, and you'll notice that the position for the diode to go has a little band printed on the board. So diode all the way down, and bend the leads out. Okay, the next component to go on can be the light emitting diodes. Now these are actually quite interesting. I'll pull out my piece of white paper so that we can look at them closely. You'll notice that the LED itself has a flat side and a bumpy side. So if we hold it up that way, I wonder if you're going to actually be able to see the flat side. The side with my thumb, there is a tiny little flat there, and the rest of the LED is nice and round. If you have a look at the board itself, you'll notice that there's a little flat on the board there. So a little flat goes there. So we can put the flat towards the flat. I put the green pulse one goes in, and the red power one goes in. Okay, now again, turn them over gently, and solder them in place. And do that one there. 1, 2. Play nicely. There we go. Trim the leads. Trim the leads. Trim leads. Always be careful when you're trimming leads to hold them and cut them, okay? Because occasionally they can fly out at a little bit of speed, and that can potentially catch you in the eye. So the next component that we'll put in the little headers. Now there's a trick with these. Sometimes you can turn, look at that. In this case we can turn them over and the headers stay in one spot. That's wonderful. So we'll take advantage of the fact, it fell out. If it falls out, don't panic. Just get a little bit of solder, fill one of the holes up with solder, place the component in partially. Now not touching the pin that we're going to heat up, gently heat up the solder, then you'll find the component will stay in one spot. Then you can start at the other end. 2, 3, 4, 5. Make sure that the component is sitting in all the way. There it is. And again we can go 1, 2, 3, 4, 5 in this case. Beautiful. Next we can put in the great big screw sockets. So in this case the 3-pin socket goes there. And again you'll see that the component doesn't like to sit in the board. So a little bit of solder on a pin, a bit of solder on a pin, and a bit of solder on the pin. And then gently place the component in. My little camera is telling me that I've got 5 minutes of recording time left, so I might have to split this construction video into 2 parts, which is okay. We can do that. So we'll just get these components soldered in first. So again, just gently, component in, get the little leg through, heat it up, let it sit. That one's in place. May as well solder these ones down. In the case of these components, don't be afraid of putting a decent amount of solder into the joint. Normally, when we're soldering, we try and use the minimum amount of soldering. In this particular case, we've got joints that have a significant amount of gap that has to be filled up, and in our case, solder is the silly putty that fills it. Okay, so here we go. Beautiful. So we've got our board at this stage there. So the next components that we're going to add is we're going to fit the IC sockets, but I'm going to hit stop now because I can't do that in the 3 minutes that's remaining. So I'll stop the video and we'll start the video with the next one.